All right, let's talk about generative AI. You've heard the buzz, right? This is the tech that's creating everything from stunning art to writing code, and honestly, it feels a lot like magic. But how does it actually work? That's what we're going to unpack right now. Let's dive in.
So let's start with the big question, the one at the heart of all of this. How in the world do you teach a machine to be creative? I mean, not just to crunch numbers or spot patterns, but to actually make something new, something original, something human. While the answer is kind of wild, it sounds like a plot from a spy thriller. You teach it to lie, and you teach it to catch a liar. You literally set up this constant cat and mouse game inside the machine, with two parts fighting against each other. And it's this battle, this duel, that sparks something incredible.
Okay, so meet player one, the generator. You can just think of this part as a super ambitious art forger. Its whole job is to create fakes. It starts with just a bunch of random static, like TV snow, and tries to turn it into a convincing piece of art, a painting, a photo, you name it. Its only mission in life? To fool the detective.
And of course, every forger needs a detective. That's our second player, the discriminator. This part is the expert, the critic. It's shown a bunch of images, some are real, and some are the forger's latest attempts. And its job is simple, call them out. Real, fake, nope, that's a fake. And here's the magic. Every time the detective spots a fake, the forger has to get better. And every time the forger slips one past the detective has to get smarter. It's this endless game of one-upmanship that forces the forger to create fakes that are, well, indistinguishable from the real thing.
So, this whole forger versus detective setup, it has a name. It's called a Generative Adversarial Network, or GAN for short. And it's brilliant. But here's the thing, GANs aren't the only game in town. They're just one part of a much bigger, much more powerful family of AI. Let's get to know the relatives.
Okay, so you've got a few main players here. There's GANs, our dramatic duo, the forger and the detective. They can produce these incredibly sharp, high-quality images, but man, they can be finicky to work with. Then you have VAs. Think of them as more like a diligent student. They're really good at capturing the general vibe of something, but their final work can sometimes be a little blurry, a little less sharp. And then there are diffusion models, which are all the rage right now. These are like a master sculptor. They start with a block of pure noise and just slowly, carefully chip away the chaos until a perfect image appears. Super stable, super diverse results, but it definitely takes a lot of processing power. So you might be wondering, what's underneath all of this? What's the engine driving these different approaches? Well, that's where something called a foundation model comes in. These things are colossal. They're these huge, pre-trained AI models that have already learned a massive amount about the world from tons of data. Think of it like the giant engine block in a car. You can then take that powerful engine and put it into a sports car, a truck, whatever you need. These foundation models are the base that almost all these incredible generative tools are built on top of.
And when you put all this technology to work, the results are just wow. I mean, they're straight out of science fiction. Let's just run through a few of the absolutely wild things these models are doing as we speak. First up, creating pictures of people who don't exist at all. These are not photos. These faces were dreamed up by an AI, pixel by pixel. Look at the details, the skin texture, the tiny reflections in their eyes. None of it is real. Or how about this? You can draw a super simple sketch, like a kid's drawing, and the AI can turn it into a realistic, full-color photograph. It understands what a house is, what grass should look like, and fills in all the blanks. It's just incredible. They can even play with time. You can give it a photo of someone, and in seconds, it can show you a shockingly realistic version of what that person might look like 20, 30, or 40 years from now. You know that thing in spy movies where they say, enhance on a blurry security camera photo? Well, now it's real. This tech, called super resolution, can take a low-quality, pixelated image and intelligently add in the detail to make it sharp and clear. And we're not just talking about flat images anymore. This stuff is moving into 3D. Generative AI can now create entire three-dimensional objects from scratch. A chair, a car, you name it, that you can then drop right into a video game or a virtual reality environment. So, with capabilities like that, you can bet people with money are paying attention. This is way past being a cool science project. We're talking about a full-blown gold rush, a massive, high-stakes bet on what's coming next. Just take a look at this number. Gartner is forecasting that by 2025, global spending on generative AI will hit $644 billion. That's not a typo. That is a truly staggering amount of cash being poured into this technology.
And the pace is just breakneck. I mean, look at this timeline. It really kicked into high gear when ChatGPT was released to the public. Suddenly, boom, OpenAI is valued at $80 billion. Then you have competitors like Anthropic getting billions in funding from huge players like Amazon. It's an all-out race to build the biggest and best models, and the numbers are just astronomical.
Okay, but it's not all perfect. With this much power and this much speed, there are bound to be some major growing pains. This technology has some serious challenges, both on the technical side and, well, on the human side.
Getting these things to work right is a real balancing act. Let's go back to our forger and detective. Sometimes, the forger just gets lazy. It finds one thing it's good at faking, say a picture of a cat, and it just keeps making cats over and over. That's called mode collapse. Or the opposite happens. The detective gets way too good, way too fast. It becomes unbeatable. So the forger just gives up because it can't learn anything. Making sure their little dance stays productive is a huge technical challenge.
And then there are the ethical nightmares. The exact same tech that generates that beautiful piece of art can be used to create hyper-realistic deepfakes, fake videos or images that can be used to spread disinformation, commit fraud, or ruin reputations. Figuring out how to handle that is, frankly, one of the biggest questions we face as a society right now.
So, with all of that on the table, the good and the bad, what's next? Where does this all go from here? Let's take a look.
The way this is evolving seems to be in three big steps. First, we had AI that did one thing well. It could do text or it could do images. That's single modality. Right now, we're in the age of multimodal AI. That's where one system can handle it all. Text, images, sound, video, all seamlessly woven together. But the next frontier, the real game changer, is what people are calling autonomous agents. This is where the AI doesn't just wait for your command. You give it a big, complex goal, and it figures out the steps, does the research, and executes the entire plan with very little help from you.
And that leaves us with one last really big question to chew on. This stuff isn't just another tool, like a hammer or a spreadsheet. It's becoming more like a creative partner. So as these machines get undeniably good at creating things, how do we redefine our own creativity? What does it mean to be an artist, a writer, a designer, when you have an artificial imagination to collaborate with? That's the question we're all going to have to figure out. Thanks for tuning in.